How are you, my friends? This is Calculus 1 Solved Questions. In this video, I'm presenting some questions about related rates, part 2. Please, you can go back and check related rates, part number 1. Question number 1, we have here a ladder 20 feet long, leans against a vertical building, as you see in the picture here. If the bottom of the ladder slides away from the building, that means X here is sliding at a rate of 2 feet per second. How fast is the ladder sliding down when the top of the ladder is 12 feet above the ground? This is the figure here. We can have a right triangle and we can start like this. dx over dt is 2 feet per second, and we need to find dy over dt. So we have a right triangle here. This is x distance, and this is y, the height, and this is 20 feet is the ladder. So from Pythagorean theorem, we can write x squared plus y squared is equal to 20 squared. And here, find the derivative using implicit differentiation. 2x dx over dt plus 2y times dy over dt is equal to 0, the derivative here. And then we have to find at y is equal to 12. So this is y equals to 12. We can find x. So we use also x squared plus y squared is equal to 20 squared. We replace y is equal to 12 here, 12 squared. And then we can solve the equation 20 squared, bring this one 12 squared on the other side and take the square root. X will be 16. You can check that, please. So we replace here x by 16, and dx over dt is given 2 plus 2 times the y value 12, dy over dt we have to find. When you simplify the equation, you get dy over dt is equal minus 8 over 3 feet per second. This is the rate of sliding down. That's why we have a negative in the answer. Question number 2, if two variables, x and y, are functions of a variable t, another variable t, and are related by the equation x cubed minus 2y squared plus 5x is equal to 16. If dx over dt is equal to 4, when x is equal to 2 and y is equal to minus 1, find the corresponding value of dy over dt. So this is also related to rates. So given the equation, x cubed minus 2y squared plus 5x is equal to 16. Let's differentiate using implicit differentiation and chain rule. So the derivative here of each term, it will be 3x squared times dx over dt minus 4, this is 2 times 2, 4y dy over dt plus 5 dx over dt is equal to 0, the derivative of 16. Now here we can take a common factor dx over dt and take this term minus 4y dy over dt on the other side. Now we have 3x squared plus 5. So the x value is 2 and the y value is minus 1 and dx over dt is 4. We can take all these values from the given. So when you simplify, you get dy over dt is equal minus 17. Question number 3 is a little application. It's a nice question. Assume that the infected area of an injury is circular. If the radius of the infected area is 3 millimeters and growing at a rate of 1 millimeter per hour, at what rate is the infected area increasing? If the radius is increasing, at what rate the whole area, the infected area, is increasing? So we know the area of this infected area, it's a circle, so the area is pi r squared. So we can find the derivative on both sides. dA over dt is equal to dA over dr times dr over dt. Now dr over dt is 1 millimeter per hour, that's given. dA over dr is we find the derivative of the area, which is pi r squared. So the derivative will be 2 pi r times dr over dt. Now the radius is 3 millimeters. From the given, we can get that. So dA over dt will be 2 pi times 3 times the 1. The 1 is dr over dt. So the infected area here, dA over dt, is growing 6 pi millimeters squared per hour. That's the answer. This is question number 4. The coordinates of a particle in the xy plane are differentiable functions of time with dx over dt minus 1 meter per second and dy over dt is minus 5 meter per second. How fast is the particle's distance from the origin changing as it passes through the point 5 and 12? So we have to find the distance between the origin 0, 0 and a point x, y. Now the given here, we can write dx over dt is minus 1 meter per second and dy over dt is minus 5 meter per second. Let's call the distance s between, this is the origin, you can imagine this is the origin and this is the point xy. So the distance will be the square root of x squared plus y squared. You know the formula, x2 minus x1 squared plus y2 minus y1 squared. Differentiate both sides using chain rule. So ds over dt is the derivative of the inside here, 2x times dx over dt plus 2y times dy over dt divided by 2 times the square root of x squared plus y squared. Now we have to substitute now from the given the 0.512. So x will be 5 and y will be 12. And also we have x dx over dt is minus 1, dy over dt is minus 5. Put all the numbers and add, divide, the answer will be minus 5. This is the distance changing. Another question number 5, the radius of a cylinder is increasing at a rate of 3 centimeters per second, the radius itself r, and the height is increasing at a rate of 2 centimeters per second. How fast is the volume changing when the radius is 1 centimeter and the height is 4? This is a cylinder here. The formula for the volume will be V equals pi r squared h. So this is the area of the circle here times the height h. So given the area V is equal pi r squared h, also given dr over dt is equal 3 centimeters per second, dh over dt is 2 centimeters per second. Let's differentiate dv over dt. Pi is a constant, we can take it outside. Inside here, we can use the product rule, u prime v plus v prime u. So the derivative here will be 2r dr over dt times h plus r squared times dh over dt. Now from the given, we have r is equal to 1, h is equal to 4, and we have also dr over dt and dh over dt. Just put all the numbers and the volume is changing. dv over dt will be 26 pi centimeter cube per second. Now for more questions on related rates, you can see lecture number 13 in the Calculus 1. And for more questions in general on Calculus 1, please, always you can visit the playlist Calculus 1 Solved Questions. Thank you for watching. If you liked the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you guys for listening.